So today we're going to be taking a look at section 1.3, which will be calculating distance and midpoints. So if you need to find distance and midpoint, there are going to be 4 formulas we use. You're going to want to write these down. First off, distance can never be negative. So if it asks you for the distance, if your calculation gives you a negative number, you're just going to make it positive. That's what the absolute value sign means. Okay? So your distance can never be negative. So the first way to calculate distance is if you're doing it on a straight line. So if you have a number line. Say it gives you -4 and 10 as your points. You want to find the distance between them? You're going to subtract. What's 10 minus -4? That gives you 14. That's all you have to do. If you couldn't remember, you could draw them in and count the distance between them. So on a number line, calculating distance is very straightforward. But most of what you're dealing with in geometry is not a number line. It's a coordinate plane. So you have more than just an x. You have an x and a y. So this formula looks really intimidating, but we're going to break it down, and it won't be so bad. So for now, write it down. I'll show you some examples. The other thing that you'll be asked to calculate is midpoint. Again, on a number line, it's pretty easy. You've only got 2 points. So you add them, divide by 2. 10 plus -4 divided by 2. That's how you find the midpoint on a line. On a coordinate plane, it's the same formula, except you're going to have 2 answers, your x point and your y point. So the formula is the same, but you're just doing it twice. So let's look at some examples. So if you flip forward to where the questions are, your first ones are finding distance on a number line. So if it asks you for x, y, x is -1, y is +7. So look back at your formula. x2 minus x1. 7 minus a -1 gives us 8. Done. This is your first coordinate plane example. You want to know the distance between each pair. So it tells you the first pair is 4, 9. The second one is 2, -3. So first thing you're going to do is write that down. 4, 9, and 2, -3. Then I suggest you go ahead and label x1, x2, y1, y2. Then we have our formula, right? x2 minus x1 squared plus y2 minus y1 squared, all then the square root. And then you just plug in your numbers. x2 is 2 minus x1 is 4 squared plus y2 y2 is a negative 3 minus 9 squared. So 2 minus 4 gives us a negative 2 squared. Negative 3 minus 9 is a negative 12 squared. Here's what I will caution you. When you put a square root in your calculator of a negative, it does not always catch this. But let's think it through. What's a negative 2 times a negative 2? Your answer has to be positive. Okay? So if you were to take the square root of negative 2, my calculator says negative 4, and yours probably will too. That's wrong. Because what we've really done is negative 2 times negative 2. So you should have 4. Okay? This is one time when you want to be careful what the calculator says. 4, same here. Okay. Now, we have the square root of 4 plus 144. Let's grab a calculator. 144 plus 4. Going to get a decimal. Okay? So, the distance between these two is the square root of 148, or 12.165. Okay? Don't let the formula scare you. Now, let's look at a midpoint question. So, question 9 asks you to find the midpoint on the coordinate plane, and it gives you the points 5, negative 3, and 3, negative 8. So, first thing we're going to do after that is write down our midpoint formula. X1 plus x2 divided by 2, y1 plus y2 divided by 2. I'm going to label these so I don't mix them up. And I'm going to plug it in. X1, 5 plus 3 divided by 2. Y, negative 3 plus negative 8 divided by 2. That gives me 8 divided by 2. And gives me a negative 11 divided by 2. So we know x is 4 and y is negative 5.5. These are points, so you can have a negative in this case. When we're calculating distance, we're finding points. So the point that is in between these two, that is the midpoint, is located at 4 and negative 5.5. That's distance and midpoint.